Guys, today we're going to make a game called Checkers, or if you're in the UK, called Drafts. And as always, we're going to model only the basic skeleton foundation of the game. The rest you could finish in your own time. And yeah, basically what I have here on the left is a wiki page for Checkers. There's a nice SVG file here, which if you click on it, you'll get something like that. And nice thing about SVGs is you could look at the source and sort of see how the things are drawn. Right, so we'll create a new package called checkers. And I already have a very small template that I use every tutorial. So I'm just going to copy this. Essentially, create root and set title. So pretty much it, but saves me from typing. We'll define tile size first. Static, well, say 100. Width 8, because we have 8 tiles. Same for height. And this is also trivial. We simply multiply it width and height by tile size. Now we'll need to have a tile class. I'll probably use a rectangle because tile is a rectangle in this case. Since there are only 2 types of tiles, I'm going to use a boolean, although I don't like having booleans in constructors or methods that take more than 1 parameter. Anyway, we also take position, and this is in board coordinates, not in pixels. So set width, essentially x, triggers and tile size. Right, we don't actually need to do this, it's just tile size. Relocate, I usually use translate x and y, but I'm going to use layout x and y because they're pretty much the same in this case. X, and we're also on to have a piece or reference to it. So I'll just create a class stands stack pane. Because as you can see, a piece is essentially 2 ellipses, so stack pane should work perfectly. I'm going to have boolean has piece to check if it's not null, so that we don't have to check it outside the class. Get piece, set piece. I also want to set fill, so if it's light, and this is where we go to source code of the SVG file, and to find that the color of the light square is actually this. Yeah, I think that's it. You can easily use value off because JavaFX works well with hexadecimal colors. Or it's a dark tile. And this is the color of the dark tile. Now we're going to create our tiles. So for I, this is height, width, tile. Right, if it's light, you can notice the pattern here. So if it's light, it's 0, 0, 1, 1, 0, 2, 2, 0. So the sum of x and y components of the position seems to give us whether it's light or dark. So it's x plus y modulus division by 2 equals 0. This is an even number, and x and y. We would want to have separate groups for tiles. And for pieces. So that pieces are drawn on top of the tiles. Right, let's see this run. Right, so we have to add it to the root node to get children, add tile, piece. Perfect. And we have exactly the same colors because we've used the source code of the SVG to check the colors. Well, yeah, so we've got the board pretty much. Now we need to get to tiles, or rather pieces. A piece should have piece type, so I'm going to create an enum. We have red pieces and white pieces. We also want to know which direction they move. So I'm going to add just one integer there to give us some info about the direction. For red, it's down, so it's positive y, or positive 1, and same for white. Actually, the opposite for white, it's minus 1. We take the type and the position, again in board coordinates. Piece type, get type. Yeah, so then we're going to create our ellipses, background. I think I use a unit, sort of relative units here. I'm going to use tile size as my 100%, which should work, hopefully. I'm just going to import this statically so that I don't have to type that every time. Tile size multiplied, there Rx is that number. Just basically with 0 front. 0.26 for radius y. Set fill. Right, we have to check the type now. Type equals it's red. Red is probably that one, and that one is probably white because it looks like white. Set stroke. Stroke is, well, they got black. Set stroke width is 003, which is then tile size multiplied by 003. We're using pretty much everything relative to tile size. So if you change tile size, you should easily be able to change the whole game's sort of size. Right. What else? We have to translate that. Actually, we'll first need to relocate the whole stack pane. Translate, we want it to be centered, which means we have to subtract from that. And the value that we're subtracting is this. This is only radius. We have to think of the diameter, so it's multiplied by 2. And then the whole thing is divided by 2 because we want to move only the half of what we get. Just something like that. Same for y, with a slightly different value though, which is this one. Yep, that looks right, I think. Get children, add all, so background first. Then the actual thing, so as you can see that we have black background and then red on top of it, which gives us sort of 2.5D kind of illusion. I think it's called isometric or something. Ellipse. Just going to call it ellipse. Actually, the whole thing is exactly the same, isn't it? Yeah. Except the color is... Wait, for that color is this. But for background color is black, actually. Background first and then the ellipse. And then background also seems to be translated. Yeah, so the background is slightly down the bottom. So we'll translate it even further in y by tile size multiplied by 0.007. So I'm just taking these values from here, from the source code of this image, and this is why SVGs are nice. Right, so we've created a piece. What else? We need to populate the whole thing now. We're going to create a method which will create me a piece. So make piece text piece type x and y. And return piece. We also probably want to make it movable, either here or... Yeah, I'll probably do it here, because each piece has to be movable. But first we need to populate the thing. So how are they placed? So they're placed only on dark tiles, and we also need to take into account the y value, which is 0, 1, 2, so it's less than 2. And that also, although the opposite, because that gave us the white tile, and we want the other one, which is dark tile. So if that's then it's red because it's the top bit. The bottom bit is similar. Zero, 5. Tile, set piece, and piece group. Probably want to have our board of tiles as well, so we get query at some stage when we actually move the thing. Alright, let's see that. Oh yeah, we have to check if the piece is not null. That looks really nice. I think it's pretty much the mirror image of what we have on the left. Right, now we have to make the pieces movable, and I'm thinking of this class because we need to do it for every piece. Yeah. So mouse pressed. We need to obtain mouse X. So this is how we can remember the mouse click coordinate, and we also need alt coordinates so we can do the move. We do it here. Move X, Y. Then alt X becomes X. X multiplied by tile size. Although it says alt X, it is now the new X. And then we can do move instead, so that alt X is remembered now. This is where we remember the click position. So mouse dragged is the actual movement. We relocate it to, right, so we get scene X minus mouse X, which gives us the difference in X, and we add the alt X. Same with Y. And then we should be able to release it, but the actual release should happen here because we want to be able to check if when we release the piece is movable to that tile. Yeah, right, but we have to also check if we can move. I think I'm going to create an enum move type because there are just two types of movement. You can either move or you can not move, and you can also skip your opponent's piece, so you kind of kill it by going over it. So there are three types: non, normal, kill. And since we're returning one of three, we'll probably need to have some sort of data structure. And if we're killing, we also want to know about the piece that we're killing. So let's get piece. And to avoid setting null from the outside, I'm just going to call or create another constructor. Let's call type. For those cases where we don't have a piece, so when we don't move or we move just one normal, then we don't have a piece to reference. Right. Can now have a method called try, or actually no, try move, which takes a piece new X, new Y. Then we check if board new X has piece. because if it has, then we cannot move. Or new x plus new y, modules division by 2 equals 0. So if it's even, actually no, is it? That's 0, 0, that's 1, 1. Yeah, so even, this gives us basically the light tile, and we cannot move on light tiles because we start from dark and we only move diagonally. So we cannot move, so return this. We probably want to have a method that converts to board coordinates given pixel coordinates. Pixel. Pixel plus tile size divided by 2 because we want it to be centered. So we get the tile we need divided by tile size. So this converts from pixel coordinates to board coordinates. x0 is going to be our old coordinate. Oh, we don't have that yet. Right. Get old y, get old x. Because we want to know the difference in block tiles when we start moving, because we can only move 1 or maximum 2 when we skip something, tiles at a time. If absolute value of new x and x is 1, so if it's either this, that, or so these directions, now we have to restrict it even further with y. Piece get type move there, because using move direction we can identify if it's moving down or up. And this is where we can move normally. Another way of moving is when we kill something. We have to do, actually it's kind of similar, but it's multiplied by 2. Yes, because it's 2 steps. That should be easier for you to see. We also need to check if in the step in between there's an enemy, because otherwise we cannot just skip. X1 is going to be that step. It's x0 plus new x minus x, which gives us the difference, and we divide by 2 to get the tile in between. Now we need to simply check. It has to have a piece, and has to have a piece of a different type. So we return type kill, and then we return the piece that we're killing. Finally, if we've gone through all of that and we haven't done anything, then we cannot move. Now we need to obtain our new x, which is board piece get alt. No, actually get layout. Yes. Because when we move it with our mouse, it relocates it and it changes layout X and Y. So we have to check if the one that we're currently moving and we're just about to release the mouse button is a tile where we can place our piece. Right, we haven't actually created anything. So move result. Result of the move, try move this piece to new X and new Y. Switch result of get type. None. Right, we have to move it back, which means we need to have some sort of photo board. This should do. So I'll put it back essentially. In normal, well, we need to obtain our previous coordinates, which is x 0. It's to board, please get alt x, because we need to clear the board at that coordinate, so that it's no longer there when we move it from that position. Piece move new x board x0 y0 clear board new x new y set piece. This one. Right, as for killing, no, actually that's going to be similar, except we also kill that other piece in the process. Results get piece. This is the piece that we passed in here. To board other piece get alt x. So basically obtain position of the piece. Set piece null. So we destroyed it in the board. Now we destroy it from the screen, which we can do by piece group get children remove piece. Actually, no, other piece. Right, let's give it a try. Now we haven't actually placed the pieces. Okay. Well, we did place the pieces. Where did they go? Right, so we don't need to do that here because we're doing it here. So this is, yeah. Right, so now I should be able to move the piece, which is nice. That shouldn't be allowed. That shouldn't be allowed, but we can skip it and kill it. Yeah, nice. That works, that works. That seems to be working. So we cannot go back. We can only go forward because of this move direction. Right, and this is how you sort of move pieces from move essentially nodes. So you can apply this kind of logic to any kind of game that you are doing if you want to be able to move various things. And I think this is pretty much done. All you need to do is maybe add a bit of logic, sort of UI, possibly a bit of logic on whose turn it is and stuff like that. And yeah, that's it for this tutorial. Thanks for watching.